right, piecewise review number part 3, writing piecewise functions. So you're going to have 3 graphs here. You're going to have to write the equation for each one. And I think what I'm going to do, I'm going to write the function up here on the right, even though it says function underneath. So let's start with the left part of our graph here. Remember, we always start with f of x, or g of x, or h of x. It doesn't really matter. We're going to have 3. We have 3 pieces of our graph, so we're going to have 3 equations. All right, now, that is a constant function. That is at y equals 6, right? That's a horizontal line, y equals 6. So I'll start with just the 6. Then I put a comma. After the comma, I put the domain. Now, since I have a closed dot and an arrow, this is going to be an array that has one number in the domain. And so the arrow is going to the left, and all those x's are less than or equal to -3. They're going out to the left. And that's it for the first part. The second part here is a line segment. That line segment, first I need to find the slope of the line. Well, it's negative. It's going down 1, right 3. So my slope is -1/3. Put my x. My y-intercept appears to be at 2, so +2. That's the equation of the line. Now the domain, it's a line segment. There's 2 numbers. The left endpoint is at -3. It's an open dot, so I'm going to put less than. Put x. Now the right endpoint's at +3, and that has a closed dot, so I'll fill in the less than or equal to. And then I have my third part. This is also a ray. Now this is a line, so let's see if I can find the slope. Looks like it's going up 2/1, so a slope of 2. The y-intercept I have to find. So let's see if I went down 2/1, I'd be here, here. My y-intercept would be at -1. And then my ray. So my arrow's going to the right, so I have all the x's that are bigger than the x value of 3. Now that's the equation. So let's find the domain and range of that function. The domain. Let's see. I go from the left here. I have an arrow on the left, so I go all the way up to -3. -3 has a value, and it then continues down that green segment here to +3. There's a value at 3. It connects to the blue segment, goes on forever to infinity. So my domain is all real numbers. My range, erase there. My range starts, let's see, the lowest value is at negative, or, oh, +1 here. Right or wrong? +1, and I go up to 3. And then I have a gap, so I really only have, my first part of my range is from 1 with a closed dot to 3 with an open dot. And then it joins together up here when I get to 5 with an open dot up, whoops, that's not what I wanted to do. 5, get my highlighter back, I guess. I go from 5 up to infinity. So that's 5 with a parenthesis up to infinity. That would be my range. All right, next one, number 6. Let's do the same thing. So I'll have my function f of x. And again, there's 3 parts to this graph, so I'll have 3 equations. The left one here is a ray. It's a line segment. So let's find the slope of this line. Looks like I'm going from here to here. It looks like up 3/1. So the slope of 3. And here, if I kept going with my slope, 1, 2, 3/1 would be at 6. So that's my y-intercept. That ray, there's a close, it's going to the left, so all those x's are less than, since it's a closed dot, we would say we're equal to the x value of -1. All right, the middle one here is a segment. It's also a parent function. Didn't change the parent function, but you should be able to identify that as the parent function of x squared. Now the domain on that one, since this segment has 2 endpoints, the first x is at -1 with an open dot, and it stops at x of 2 with a closed dot. So that would be the domain for that parent function x squared. All right, finally the third one is another segment, and it's a line. The slope of this segment is down 1, right 1, so -1x, or you can just write -x. If I continued this, It's a little hard to see, but it would probably cross at 9. So negative x plus 9. The domain here goes from 2 with an open dot until 7 with another open dot. All right, there's my equation. Let's write the domain and range. So my domain here, let's look from the left. I have an arrow on the left, which means I'm going from negative infinity. I get to negative 1, I have a value. I also connect down to this bottom graph here, so I continue to 2. 2 has a value and it connects with the top equation that continues till 7. So my domain goes from negative infinity to 7. Both parentheses there because the 7 has an open dot. Now the range, I start at the bottom. The bottom has an arrow, so I'm going up, 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 up. I'm still going up here. At 3, I can still go up. At 4, there's still a value. And there's values over here, so I actually continue up to 7. So that range is from negative infinity to 7 with an open dot as well. So the domain and range are the same. All right, last one for part 3. All right, I have 1, 2, 3 parts to my equation because I have 3 pieces of the graph. So the left part here is a constant function that happens at negative 3, y of negative 3. And since it's array, the arrow is going to the left. I want all the x's. It's an open dot that are less than negative 5. This middle piece here is also a constant function. That constant function happens at y equals 5. It's a segment. So I have 2 endpoints. The first endpoint's at negative 2. That's a closed dot. And I have an open dot at 0. All right, the last piece here is another parent function you should know. That's the square root of x. Okay, that's the function. I didn't change it. And it's array. I have a closed dot at 0. And since I'm going to the right, I want all the x's that are greater than or equal to 0. All right, let's do our domain and range. If I start on the left, I have an arrow. I'm connecting here to negative 5. And I don't have anything else. See how there's kind of a gap here? There's no x's. So my first part of my domain is just from negative infinity to negative 5. Then I take a break. Then I pick back up with my domain at negative 2. Then when I get to 0, I have value and I continue going to infinity. So my domain comes back at negative 2, which is a square bracket because it's a closed dot, to infinity. All right, let's talk about Let's talk about the range here. All right, my range is, let's see, have just the y value of negative 3. And then I have a gap. I don't have any y values until I get back up to the next part of my function. So the first part of my range is just the number, negative 3. Then, when I get up to this square root function, that square root function goes forever. It has an arrow going up forever, so it continues up to infinity. So I'll join back in at 0, inclusive, to infinity. All right, one more part, it's applications. Come back for that video if you need.